Hello and welcome to the Autodesk Fusion 360 5-axis machining tutorial. This is part 1 of a part 2 tutorial where we will be machining a complex mid-housing of a gearcase. In this tutorial we won't be machining the component in the most efficient way. We will just be showing you different ways to machine complex geometries. So the first thing you want to do once you have your fixture and your component imported is you want to make sure that it's aligned. If it's not, you need to move your component so that it's in the middle of your fixture. And you want to right click setup, select new setup. You can see here you can select which machine you're going to be using. Fusion 360 has machines already on the program that you can choose from, or you can put your own in as well. So I'm going to select the generic 5-axis machine here, and then if you go down to your work coordinate system, WCS, you can set up your axes and your coordinates for the middle of your component. So you need to select the middle of your component. So we'll select the point. And if we select this circle, you can see it's going in the middle here, which is where we want to put it. So then you also select your model, which is your component. So if we can rotate this, and you can see if we highlight over or hold over this, we can select all of it at once. And then you down the bottom here, you have to select your fixture. So if we select that and include these two bits as well, and that looks good. So we move on into the stock. You can see all your options here. If we just rotate this around, we have left a slight gap between the component and the fixture, but that is for the additional stock, the offsets. And we're going to go with a relative sized box here as the stock. Of course, if we used a billet, we would have less waste material, but just for the tutorial purposes, we're going to go with a relative sized box. So we offset here just enough. We go 3.5 here. You can see it's right up along the edge of the fixture. So we click OK. That looks good. Now, if we go back into the setup, you can see here your program and your machine WCS, and just additional options on the end of the setup. So now this looks good. You can see your stock. This looks good to start machining. What we want to do now though is if we start off with a face mill, you can see here all of the tools that we can use. So we want to select mill, face mill, and then you can see all of the suitable tools that we can select. So if we go for the 50 mil face mill, you can see here your feeds and spindles, contours, and your tool orientation. So the orientation is vital that you get right. So you can select, you can see here it's the wrong side. So if we flip the axis, you can see it changes the side that it's going to machine. So it's now machining the top of the component rather than the bottom. We change the origin to the model origin. We've already set the WCS origin to the same place in the middle, so it shouldn't really matter. Now if we move on to our heights, you can see your clearance, retract, feed, top and bottom heights. Because we're doing a face mill, these heights won't really matter too much, because if you're doing a face mill, the maximum you'll be taking off is a couple of mil, just down to the top of the component. So you move on, you can see your passes, your multiple depths, if you want to leave some stock, and your linking. So we're all happy with that. We'll hit OK. You can see here it simulates the machining process. So if we simulate here, you can see that the tool is in the right starting position. You can see your stock, and if we just play this through, that looks good. So you can slow it down and speed the simulation up, which is good for spotting any errors or collisions. So if we could move on then to 2D adaptive clearing for the inside of the middle housing. So if we select the tool, we're going to go for a flat end mill, because remember again it gives less rest material to machine later on. So if we select the 14mm diameter flat end mill, and actually if we go back into it here, you can see it gives different options for the tool. So if we select brass roughing, because it's not a finishing process or a finishing machining operation, and then we select our tool orientation, our origin. Remember, we have to flip our axes. And if we select this contour here, you can see that it's going to machine around this contour. We select tangent. And we can move on now to our heights. And the heights are very important for the adaptive clearing on the inside, because there is certain areas that we don't want to machine for this operation. So if we select here, first of all, see how this machines, and we move on, you can see your stock to leave, that's all fine, and your linking. So if we leave that as climb milling and select OK, you can see here, this is not what we want to see. Before actually we change it, we'll just simulate this through. You can see this shouldn't be coming up, this shouldn't be shown after a machining operation has been completed. So if we simulate this, you'll see what I mean now. If we play this through, you can see down along the bottom bar, there's no red marks to show any collisions. But if we look closely at the simulation, the tool actually goes through our component. So you can't have that, because then you're just missing areas of your component. So if we zoom in here, Fusion 360 doesn't actually give any notification or details on a collision with the component. So if we see here, the tool just goes straight through it, which obviously isn't good. It's not what we're looking for. So we need to raise the bottom height of our machining operation. So if we go into edit, and if we go to heights, we can raise this bottom height up to here. So we select OK and see how this machines. You can see again that it has collided with the component. So we again need to raise the height. So if we raise it up to this line, this is where the changes are happening. So if we go above here and then machine it, you can now see that it's not colliding with the component at all, and that looks like a good machining process. So if we simulate it through here, you can see your timings, your distances, and that all looks good. So next what we want to do is we want to go to 3D pocket clearing, and select our tool here. If we select bullnose end mill, and we select 8mm brass roughing tool, we select rest machining and machine cusps, so it'll just machine any cusps that haven't been machined or were left from previous machine processes. Your orientation again, making sure it's the right side of your component, of your fixture. Then your heights again. We know the importance now of making sure that your bottom height isn't too low. So again, if you put the top height to where the adaptive clearing, the 2D adaptive clearing left off from, because again, that's just making your machining more efficient. You're saving time. It's not having to machine areas that are already machined. So here we reduce our roughing step down. Fusion 360 automatically gives you a notification if it is too high. So if we select OK here, you can see our machining is being programmed. So if we go ahead and hit simulate here, you can see your timing, your distances again. You see red bars along the bottom, which isn't good. That means our holder has collided with our component. So yeah, you can see there's a lot of collisions here that need fixing. So if we go in and change our tool, change it to slightly longer flute, which means the holder will have more clearance. So if we select the 10mm here, you can see once it's been processed, if we hit simulate, there's now no red bars along the bottom, which means there's no collisions between the holder and the component. Slightly longer time, obviously because there's a smaller diameter on the tool. So that machine process has been completed. It looks good. So what we're going to do next is we're going to go for 3D contour. Select our tool here first, if it's going to load for us. Okay, so we're going to go with a flat end mill again. We're going to go with the 10mm diameter, 40mm flute length. We're going to leave the boundary as silhouette, again selecting our appropriate orientation, origin, and leaving machining cusps on. We select our heights now then. So we'll leave those like that for now. Everything else looks good. So if we click OK here, so now that that operation has been completed, we can move on with a 2D contour. I'm going to get a slightly smaller diameter flat end mill. So if we select the 5mm diameter here, and brass finishing variation, we're using this contour on the top again, making sure our orientations and origins are correct. Now for the heights, remember we want to keep the bottom height high enough so it doesn't collide with our component. And make sure everything else is in order. Then we click OK. So if we simulate this through, you can see your timings and distances and no collisions along the bottom with the holder and the component. And that looks like a good operation, clean operation. So moving on then from our contours, we're going to go for a 3D pencil mill. And if we select our tool, we're going to go for a ball end mill with a 10 mil diameter, 5 mil corner radius. Making sure again orientations and origins are correct. We're going to put rest machining on so it machines cusps left over from previous operations. We're going to select contact point boundary, and if we select the model here, we can actually select certain faces that we want machined. And I know that these areas are all 5 mil radius, so if we select these, the tool should be the right size to machine them. And we're going to do avoid or touch surfaces, and we're going to select the same surfaces and then tick the touch surfaces box to make sure that these areas get machined. So if we select here and then move on to our heights, and they look okay. Step overs, you can change your number of step overs or the step over distance. So we'll just change those slightly and then make sure linking and passing is all good. And you can see here it's machined the fillets on the inside of the mill housing. And there is collisions between the holder and the component, so that's going to need fixed straight away. So if we just rotate down here, yeah. So if we go into edit, if we add a shaft and a holder, we can increase the clearance between the holder and the component. So if we increase this number and then hit OK, okay, so there's a warning has come up. The tool was updated to ensure the holder doesn't collide with the part. So if we edit that again and just decrease this slightly and then rerun the operation, you can see it's been completed now with no warning. If we simulate it through, there's no collisions along the bottom. So if we simulate this now, yeah, so that looks good. It's a fairly short machining operation for machining inside fillets or interior fillets. So if we look at the finish here that it's left on the fillets, it looks good, it looks smooth. So if we move on, then we're going to select 3D horizontal machining. And here again, we're going to select a flat end mill. We're going to go for the 10 mil diameter, 40 mil flute tool again. So if we select bounding box and inside bounding box with no additional offset, and then select the correct tool orientation and model origin. So if we select these flat areas that we want machined, we've already machined the very top with the face mill at the very start, so we don't need to machine that again. If we have a look at our heights, going to start from the model top. We can actually start slightly lower than the model top because we're not machining it. Remember, we already machined the top of that whenever we're doing the face mill. So if we hit OK here and see how the process turns out. It takes slightly longer because it's machining more areas, separate areas. So if we simulate this through, you can see along the bottom there is one collision which we will need to fix. So if we just have a look at this. There's a collision with the stock. So I think if we adjust the bottom height of the machine in operation, it should fix the collision. So if we close this, edit the horizontal operation, and from this angle we'll be able to see the depth that it should go to. So if we hit select for the bottom height and we select this line with this edge, then that solves the issue. So what we're going to do next is machine these small fillets. So if we go 3D pencil mill and we select our tool, so we're going to select a ball end mill with 5mm corner radius. We're going for a brass finishing variation. So if you select contact point boundary, rest machining, machine cusps. Again, tool orientation is very important. That's machining the right side. So if we select here, avoid touch surfaces, and we wanted to touch these two fillets, and we select OK. Well, one thing we need to do before is the step overs. So we're going to increase the number of step overs and decrease the distance. And if we select OK, and if we simulate the operation, you can see it machines it pretty well. So that's all down to the correct tool size for the internal fillets. So if we go to 2D pocket mill now for our next operation, and we want to machine straight through this pocket, so we're going to need a long tool just to avoid any collisions. So we're going to go to 10mm, 40mm flute length. And if we select this pocket section, and kind of enclose this pocket, just make sure orientations and origin is correct. So again, you have your heights. So we want to start this pocket from this line, and we're going right through to the stock bottom. can change our maximum step over. We're going to reduce this. And stock to leave, that's all okay. So that looks good. Looks like it's going to machine the inside. We don't want to machine the outside line, because then that's taking the chamfer into account, which is not what we want to do. And if we change this stock to leave to maybe 1.5 mil, because we do want a good finishing operation on the walls of that pocket. So if we simulate this operation, you can see along the bottom there's no collisions. There's one collision now with the component just on the holder. So if we have a look at this collision, yeah, you can see the holders just colliding with the inside of the mid housing. So if we edit the radial stock to leave and maybe add another 0.5 mil onto this, simulate it again, we'll notice now that collision has been removed, because there's just enough space for that holder to move past the inside of that mid housing. So that looks good. You can see how close it gets here to the edge. That's where the collision was happening, but it's got enough clearance now. So that pocket looks good. Now if we just have a look at it from this angle, there is a possibility we could machine straight through this pocket. You'll see that there was a bottom on it. So if we go to our heights again, and we just move this height down a couple of mil so that it machines right through the other end of the stock. So if we have a look at it again, yeah, you'll see there's no collisions, and now it is machined right the way through our stock. So our next operation, we're going for 3D contour again, and we're going to select ball end mill, flat end mill, and we're going for a 10 mil diameter, 40 mil flute length again. And we're going to go bounding box, and we're going to select our orientation and origin again. We're also going to ensure that it touches these surfaces along the inside of this pocket. So this is just removing the extra material that we left with the last operation. So if we again select our heights, and once you're happy, select OK. can see here that it's machined right the way through. So if we simulate this operation, you can see we have a few collisions here that will need sorted. Yeah, and one thing we can see here is that we didn't flip the Z axis. You can see how important it is to make sure your orientation is right. Simulate it again, this time machining it from the correct angle, with the correct side. We still have collisions, and not as many, but they are more consistent. And it is with the holder again colliding with the component. So if we add some clearance onto the holder, you can see there's some issues with the other machining operation. So if you just right click and hit generate again, it'll just regenerate those operations, rerun them, see if there's any issues. Now, see here the tool length has been changed, so now we need to make a few changes. So if we decrease this holder clearance and rerun the operation, you can see here along the bottom all of the collisions have been removed, and it's now successful finishing operation for the inside of that pocket. We can add rest machining to machine the cusps that were left from the last operation that should have been on. So hit OK again. If we go ahead and simulate the operation, so you can see that gives a good finish on the inside edges of that pocket and no collisions. So that operation looks good. I'm happy with that, and it's right the way through to the bottom of the stock as well. So we're going to move on now with a scallop, 3D scallop, and we're going to use bull nose end mill. We're going to go for a 3mm diameter, 1mm corner radius. We're going to select bound and box and make sure orientation and origin are correct. And then again, we're going to hit touch surfaces, and we're just going to select this chamfer along the edge of our pocket. Okay, so now make sure our heights are okay. And once you're happy, you click OK. And you can see the correct areas are being machined, so you go ahead and simulate it. Machining operation looks good, so it's given a good finish on the chamfer around the pocket. So it's a successful operation, so we move on to the next one. The next thing we're going to do is we're going to do a drilling operation, hole making drill, and we're going to select the 10.2 diameter. We're going for high carbon steel, and we're going to drill straight through the center. Tool orientation again, vital that you get this right. And again, for your bottom height, you want it to drill the whole way through, so you need to select stock bottom and add a negative offset. Or you could drag the stock bottom down manually, it's up to yourself. So once the operation's been programmed, simulate it. And that looks about right. So next what we're going to do is we're going to do 3D scallop again. And we're going to use a ball nose end mill. We're going to go for a 3 diameter 1 millimeter corner radius, rest machining on. Tool orientation must be right again. And we're going to use the touch surfaces bar. We're going to just machine the chamfer in the middle, on the middle hole. So select our heights here. The top height needs to just be the top of this chamfer, and we'll do it 1 mil either way for the top and the bottom. Make sure everything's okay. Once you're happy, continue. Okay, so we hit simulate here, and yeah, that looks good. There's no collisions. And that chamfer looks good. So what we're going to do next is we're going to go for a 3D pencil mill, and we're going to select ball end mill. We're going to go for a 10 millimeter diameter, 5 mil radius, brass finishing variation. And we're going to go binding box, contact. No, we're not going to put contact point boundary on. Rest machining, machine cusps. And again, orientation and origin. And we're going to use the touch surfaces feature again. And we're just selecting these corner radii. We can change these heights just to save on time and avoid extra collisions. And you can see from the simulation here that the operation looks good. So the next thing we're going to do is another scallop operation. We're going to go with a bull nose end mill this time, 3 mil diameter, 1 mil corner radius, brass finishing variation. Again, we're going to use binding box. We're going to use rest machining. Ignore the cusps. Tool orientation, origin, and then we're going to use the touch surface feature again, and we're just selecting these edges for the 1 millimeter chamfer. So we'll move on to heights then. And again, just moving your bottom height up and making sure everything else is okay. So we'll go ahead and simulate this operation. No collisions. So next we're going to do a 3D pocket mill with 3mm bull nose, 1mm corner radius. We're going to use stock contours, center on bounding box, machining the cusps with the appropriate tool orientation and origin. The contours are just for containing the tool in. Just machining the inside pockets. And then the height is adjusted to suit the pockets just below the bottom of the pockets so that it does machine it the full way through, making sure everything else is in order. And then clicking OK when you're ready. So we'll simulate this. And you'll notice I moved this up ahead of the scallop, the last scallop and the last pencil operations. There's no real reason for that. I just prefer doing putting the pockets first. So yeah, that operation looks good. Pockets successfully machined and no collisions, so that looks like a good operation. So next what we're going to do is we're going to machine these holes on the top surface of the mid-housing. So if we go hole making and select the appropriate size drill bit, 6.8mm diameter for the smaller holes. And we select all three of those. And remember, ensuring your tool orientation is correct. Your heights, Fusion automatically sets the bottom height to the whole bottom, so you don't need to worry about that. So we'll simulate this through, and you can see machined those holes successfully and no collisions, so that's always good. Now what we have left to do is machine the other two holes. So we are 8mm high carbon steel, and then select your two holes again with your orientation, again automatic hole bottom, so you don't need to worry about that. Simulate it through just to make sure there's no collisions. And again, that looks good. So what we're going to work on now is these chamfers at the top of the top surface. So we're going to go use the 3mm diameter, 1mm corner radius bull nose end mill again. So we're going to use bounding box, machining cusps, appropriate tool orientation, and then using the touch surfaces feature again, and just selecting these surfaces where the chamfer is applied. And although one chamfer is larger than the other, because it is a 1mm corner radius, Fusion will machine all of the chamfers at once with more than one step over, obviously. So you can actually manually set the step over distance, but we're going to leave it as it is. Let's see how this turns out. Of course, you could split this up into more than one operation if you wanted to, but we're just going to do it as one. So we simulate it through here. Again, no collisions, nice clean operation, and that looks good. So next what we want to do is we want a 3D contour of the inside pockets of the mid housing. So we're going to use a ball nose end mill, a 3mm diameter, and what we want to do is we want a finishing operation on the walls of the pockets of the inside of the mid housing. So we do machine cusps, and if we change the machining boundary to selection, what we want to do is select these contours around the outsides of the pocket. But what I found with when selecting these contours is it can sometimes be easier if the tool orientation is turned off. So if we turn the tool orientation off and then select our chains, you'll be able to see here that it's actually slightly easier to select them. So I'm going to speed this up when I'm selecting the contours, and I'll be back once they're ready to go. So now that we have the contours selected, you can turn your tool orientation back on. You can see at the minute they're the wrong way around, so if we just select the correct plane, you can see the move or the switch positions, and they are in the right orientation to be machined from top down. So again, just selecting your appropriate heights to suit the pockets. So once you're happy with all your settings, click OK. So you can see here the toolpath has been generated and the resulting stock has been updated. So that looks good. And if we move on to scallop next, and this is going to be used for the chamfers around the insides of those pockets. So we're going to use a 3mm, 1mm cornered radius ball nose end mill. Again, selecting your orientation, machine cusps, and what we're actually going to do is we're going to change this to selection in the machine boundary, and again we're just going to select these contours. So again, sometimes it can be easier selecting your contours without tool orientation. So just finding the best way to select what you're looking, the most efficient way. Sometimes it takes a bit of trial and error. So there, once you're happy with your contours and your chains, select the appropriate heights again. And once you're happy, click OK. Now that looks good. You can see it's machined right along the chamfers on the insides of the pockets. So if we simulate it here, yeah, you can see by the movement and shape of the tool and the holder that it is machining along that chamfer. We have got a collision down there along the bottom, so we'll get to that, that'll have to be fixed. And we can use the touch avoid surfaces. So if we select the inside surface and leave it at 0.01 mils, and then hit OK, see if it still collides with the inside surface. So if we simulate the operation again and see if there's any collisions. Yeah, so there is another collision, again with the inside edge. So if we open up the scallop again and go back to the touch avoid surfaces, and we change this to 0.1 mil instead of 0.01, it should give us 10 times the amount of clearance, although it is still a very, very small amount. Once this has generated, simulate it and then see has that solved the collision issue. So we simulate it again, and there you can see along the bottom there's no collisions, so that issue has been solved, and it gives a good finish on the inside chamfers. So that looks good. I'm happy with that. So that'll be it for today's tutorial. Join me in the next one to see how you machine the other half of this component.